Imagine a place where the ground literally writhes, where rivers of lava flow across frozen plains, and where the sky is torn by plumes of fire that extend into space. A frozen hell, violent, unpredictable. Today, we're going to travel more than 370 million miles from Earth to visit Io, the most insane moon in the entire solar system. A true volcanic nightmare that defies everything we believed we knew about moons. But why does this place, so distant from the sun, emit so much heat? And what is happening beneath its crust to transform its surface into a battlefield between fire and ice? Buckle up. You're about to discover a world that pulses with incessant fury. Io, the moon that never sleeps. Unlike the other moons in the solar system, cold, calm, and marked by ancient scars, Io is a living body, a geological organism that trembles, spits, explodes. It is the undisputed champion of volcanic activity. More than 400 active volcanoes, plumes that reach hundreds of miles into space and temperatures that, in certain regions, exceed 372 degrees Fahrenheit. To understand why, we need to look at its orbit. Io orbits around Jupiter, the largest planet in our system, at just 261,000 miles away, practically glued to it. This proximity, combined with a phenomenon called orbital resonance with the moons Europa and Ganymede, causes Io to be stretched and compressed without stopping. Eruptions happen in gigantic calderas, in deep fissures, in depressions that open and close like geological wounds. The surface, far from being static, is constantly renewed. Impact craters barely have time to exist. But Io's appearance is perhaps the most bizarre spectacle. It looks like a surrealist painting. Vibrant yellow, bright red, green, and white patches, all shaped by sulfur compounds in different states and temperatures. The yellow comes from crystallized sulfur. The red from short sulfur molecules and dioxide exposed to heat. The white, sulfur dioxide ice. And the green, a possible signature of mysterious sulfur monoxide, unstable here on Earth, but common in this cosmic pressure cooker. This surface constantly changes. The volcanoes don't just explode, they redecorate Io in real time. An example is the Pele volcano, which forms a gigantic reddish ring around its mouth, the result of hot materials that rise, cool, and react with the cold around them. The plumes, composed of gas and fine particles, fly 186 miles high before raining again on the landscape. Io covers itself with a kind of chemical snow after each volcanic breath. Even its atmosphere is a paradox. Technically, it exists, composed mainly of sulfur dioxide, but it is so tenuous that it can barely be called an atmosphere. And this activity isn't just superficial. Scientists had suspected for years of the existence of a global magma ocean beneath the moon's crust. But recent observations from NASA's Juno mission began to tell another story. Each of these magma pockets can generate a complete volcanic system. It's as if each volcano had its own internal power plant. And many of them have cyclical behaviors. Loki Patera, for example, is an immense lava lake the size of Lake Ontario. Others, like Prometheus and Pele, also have localized and predictable eruptions. This indicates that Io's interior is a dynamic mosaic of independent internal pressures, functioning like an uncoordinated orchestra of boiling cauldrons. And all this occurs under constant bombardment from the space environment. Io is embedded within Jupiter's powerful magnetosphere, which means that highly energetic particles are always interacting with its surface. This radiation bath alters chemical compounds, affects the crust's coloration, and possibly even interferes with volcanic activity. The nature of the volcanoes is also impressive. Unlike ours, On Io, there are no majestic mountains with smoking peaks. Many of the volcanoes manifest as wide and deep depressions, where the crust collapses to reveal vast magma chambers. The walls of these calderas crumble, creating dramatic cliffs. The result is a landscape more like an apocalyptic battlefield than any terrestrial scenery. And however chaotic it may seem, this dance of destruction has logic, a pattern. Io doesn't go dormant. There is no geological winter, no breaks. At any moment, dozens of eruptions can be happening in different regions, reigniting the surface, throwing ashes, melting what had solidified hours before. And the most impressive part, we're just beginning to understand it. With each new pass of the Juno probe, new images and data arrive, revealing a celestial body that doesn't just change, but pulses with real geological life. Io shows us that even the most unlikely places in the cosmos can hide profound, complex, and frighteningly beautiful dynamics. If you found this dive into Io's frozen hell as fascinating as I did, don't forget to like the video, subscribe to the channel, and hit the bell to continue exploring the mysteries of the cosmos with us. And look, there's a video here on the side that will take you straight to another insane journey through the solar system. Click there right now. Until next time. And keep looking up. The universe has much more fire to show.